Welcome to the fascinating realm of artificial intelligence, where a technology known as Chat GPT, Generative Pre-trained Transformer, has been making waves in recent years. This incredible technology has advanced by leaps and bounds, showcasing its ability to comprehend and generate human-like text, revolutionizing AI communications. In this article, we will delve deep into the core concepts of Chat GPT, demystifying its inner workings and exploring the technology that drives it. Rest assured, we'll present these complex ideas in a manner that is easily understandable for everyone. The name, GPT, is an acronym that stands for Generative Pre-trained Transformer. Each letter in the acronym represents a crucial aspect of the technology. G denotes generative, indicating that Chat GPT is capable of creating new original content. P stands for pre-trained, signifying that the model has been trained on a vast corpus of text and language data to understand human communication. T represents transformer, which refers to the type of neural network architecture employed by GPT to process and generate text. In essence, Generative Pre-trained Transformers, GPT, belong to a family of neural network models that leverage the transformer architecture and undergo training on extensive text data for various language tasks. This makes GPT a potent tool for generating natural language text, an essential concept in large language models within the realm of AI. The foundation of Chat GPT lies in large language models. To comprehend this concept better, let us consider an analogy. Imagine finding yourself in a foreign country where you don't speak the language. In such a situation, you would need to swiftly pick up on patterns, common phrases, greetings, or gestures to navigate through the unfamiliar territory. Similarly, large language models in AI embark on a similar journey. They learn the patterns, rules, and nuances of a language purely from the texts they are exposed to during their training. The internet serves as a vast metropolis, comprising diverse neighborhoods of different languages, dialects, and slangs. Large language models, like GPT, act as explorers charting this linguistic landscape, gaining insights into local customs, syntax, cultural nuances, semantics, and even contextual language and dialects. Consequently, GPT not only understands and generates text but also paints a linguistic picture as vibrant and intricate as the language itself. To fathom the inner workings of Chat GPT, let us take a closer look at its architecture, analogous to exploring the mechanisms of a grand, intricate clock. At the core of this clock are the transformer blocks, the gears responsible for keeping the hands moving. Each transformer block functions as a tiny knowledge processing unit, much like different departments in a bustling city office, each with its own distinct function. When you input a sentence into Chat GPT, it's akin to handing a package to a runner in a relay race. The first transformer block, acting as the initial runner, unpacks the meaning of the sentence, adds additional context, and passes it to the next runner. With each pass, the package becomes richer in nuanced contextual understanding. Finally, the last transformer block serves as the anchor of the relay team, ensuring that the package is filled with a comprehensive comprehension of the text. These transformer blocks working harmoniously form the bedrock of GPT's ability to comprehend and generate text, akin to hidden conductors orchestrating an AI symphony of language understanding. Understanding the training process of Chat GPT requires embarking on an imaginary journey. Picture a young, curious child eager to learn. The child listens to conversations, reads books, asks questions, and gradually begins to understand language. In a similar vein, Chat GPT initiates its journey knowing nothing about language, with its books comprising an extensive array of internet text. During the training phase, the AI is exposed to this vast data not to memorize it but to learn the underlying rules, patterns, and structures of language. It operates as a detective, observing clues and connections, and forming an understanding of how language works. However, unlike a child's real-time learning, GPT's training process is frozen after its training period. It captures the world of language as it existed during training, unable to learn or adapt further without additional training. Context comprehension is paramount to Chat GPT's functioning, and it involves an intriguing process. Imagine a conversation as a string of beads, where each bead represents a statement, question, or response. When you add a new bead to the string, it does not exist in isolation. Rather, it is connected to all the beads that came before it, carrying the entire history of the conversation. Chat GPT operates in a similar manner. When you input a new statement or question, it does not merely consider that standalone input. Instead, it takes into account the entire conversation history that led to this point, encompassing all the previous inputs and outputs. This comprehensive view allows Chat GPT to process each input as a continuation of the conversation, which, in turn, influences the model's responses. This ability to track and understand context is facilitated by GPT's underlying transformer architecture. Transformers can handle long-range dependencies in text, enabling them to link related concepts or ideas, even if several other sentences come in between. Consequently, Chat GPT can maintain context over a session and generate coherent, relevant responses. Generating responses with Chat GPT can be likened to a game of predicting the future. Given a series of words or phrases, GPT attempts to predict what comes next. It does so by utilizing patterns it learned during its training period, much like a world-class chess player who anticipates their opponent's moves based on past games. The prediction process is a product of a machine learning method known as transformer architecture. When you type in a phrase or question, Chat GPT undergoes a process akin to rolling a very complicated set of dice. It considers the possible words that can logically follow the given input based on its training. Each potential word is assigned a probability, representing how likely it is to be the next word. For instance, if you typed, "the cat chased it," the model would assign high probabilities to words like tail or prey, and low probabilities to unrelated words like spaceship or breakfast. This is because in its training data, it likely encountered sentences where cats chase their tails or prey far more often than they chased spaceships or breakfasts. However, instead of always choosing the most probable word, which could lead to repetitive and monotonous responses, Chat GPT introduces an element of randomness. This means that it occasionally selects less probable but still plausible words, injecting dynamism and a human-like quality into the conversation. If you found the insights shared in this article helpful and intriguing, we kindly request your support in the form of likes, shares, and subscriptions. Liking this article will let us know that you appreciate the effort put into making complex concepts accessible to a wider audience. Sharing it with others will help spread knowledge and understanding about Chat GPT and its remarkable capabilities. Lastly, subscribing to our channel will ensure you don't miss out on future content that delves into the exciting world of artificial intelligence and other groundbreaking technologies. Thank you for joining us on this journey of discovery, and we look forward to your continued support. Together, we can explore the fascinating world of AI and unlock its full potential.